Yesterday we solved quadratic equations using factoring. Today we are going to solve using the quadratic formula. Now if you look below, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And again, like we saw yesterday, the a is the number in front of the x squared, the b is the number in front of the x, and the c is the constant or the number by itself. What you'll end up doing is, given an equation, plug into the formula. And if you're asking yourself, do I need to know this formula for the Regents exam? The answer is yes. It is not given to you. You do need to eventually memorize it. So let's try the quadratic formula with these two problems here. For this first problem, it's set equal to 0 already. So I'm just going to list what my a, b, and c are. A is the number in front of x squared, so it's a 3. B is the number in front of x, so it's a negative 5. And c is the constant, it's a positive 2. Or you can just put a 2 there, you don't need to put positive 2. Now what I'm going to do is plug into the formula. So it's going to be x equals negative b, so 5, plus or minus the square root of b squared, which is 5 squared, 25, minus 4, a is 3, and c is 2. It's all under the radical. All over 2 times 3. What I'm going to do next is simplify that radical. So I rewrote 5 plus or minus. Now if you type in your calculator, please don't type the radical. Just do 25 minus 4 times 3 times 2. You'll end up getting 1. So underneath the radical is just a 1. 2 times 3 is 6. Well, we know the square root of 1 is 1. So this is really 5 plus or minus 1 over 6. At this point, when you have a nice number like 1 in that second half, I'm going to ask you to split it into two problems. You're going to say x equals 5 plus 1 over 6, and x equals 5 minus 1 over 6. Well, when you saw 5 plus 1 is 6, divided by 6 is 1. 5 minus 1 is 4, divided by 6 is 4/6, which reduces to 2/3. So x equals 1 and x equals 2/3 are your final answers. And that's it for that problem. You have your answers there. Let's try the next one. And I'm going to have to try to find some room to fit all of this in, but we'll start right next to it. We have x squared minus 3x equals 0. It's already in standard form, so let's list our a, b, and c. A is 1, b is negative 3, and notice there is no constant, so c is 0. Let's plug into our formula. So it's going to be x equals negative b, which is a 3, plus or minus the square root of b squared. Negative 3 squared is 9. When you square a number, whether it's positive or negative, your answer is always positive. So if you typed negative 3 squared in your calculator and got negative 9, you need to use parentheses around it. So b squared minus 4, a is 1, c is 0, all over 2 times 1. Well, if you look under that radical, 4 times 1 times 0 is just a 0. So we really have 3 plus or minus the square root of 9 over 2. The square root of 9 is also a nice number. It's a 3 over 2. Again, at this point, we separate it into two problems. Let me see if I can find some. I'll write it over here. We will have x equals 3 plus 3 over 2, which is 6 over 2, which is 3. Sorry, that's a 3. Let me erase and do it over. And then we would also have x equals 3 minus 3 over 2, which is 0 over 2, which is just a 0. Now these two problems actually worked out very well. We got nice numbers. That does not always happen. Let's look at our word problem now. We have a couple word problems. I will at least set these up. I don't know how much we'll finish of these. It says one leg of a right triangle. So I'm going to start by drawing a right triangle. One leg of a right triangle is 1 centimeter shorter than the other leg. So maybe I call this leg X, And it says the one is 1 centimeter shorter, so it would be x minus 1. And the hypotenuse is 2 centimeters longer than the longer leg. Well, that's 2 centimeters longer than x is x plus 2. We want to find the lengths of the sides of the triangle. Well, it's a right triangle. And the relationship or the formula that deals with the sides of a triangle is Pythagorean theorem. So I could say x squared plus x minus 1 squared equals x plus 2 squared. For this one, I really only cared about the setup. We would keep going here and solve it. I'm not going to spend the time to do it on the video right now because I want to spend the time to do the next word problem in the video. It says the larger of two numbers is 5 more than twice the smaller. Well, if I say the smaller is x, the larger number is 5 more than twice it. Well, twice the smaller is 2x. 5 more than it is 2x plus 5. And then it says the square of the smaller, that means x squared, equal to the larger, so 2x plus 5. Then it wants us to solve it. Well, the way we solve anything with a squared is to set it equal to 0. So what I'm going to do is I'm going to subtract the 2x and subtract the 5. And maybe you're looking at this and saying, all right, let's try to factor it. Well, factors of 5 are 5 and 1. And that's it. So is there anything you can do with adding or subtracting a 5 and a 1 to get to a negative 2? The answer is no. Since the answer is no, you have to use the quadratic formula, which we learned above. And you can go back up to the top of your notes if you don't remember your quadratic formula yet. But I'm going to start plugging in. It's going to be x equals negative b, so 2, plus or minus the square root of b squared, which is 4, minus 4 times a, which is 1, c, which is negative 5, all over 2 times 1. So we would have x equals 2 plus or minus the square root of, and if you type in your calculator again without the radical, you do 4 minus 4 times 1 times negative 5, you get 24. Well, 24 is not a perfect square like it has been for the other problems. But we can simplify it. 24 breaks down to, let's do it up here. 24 breaks down to 6 and 4. 4 breaks down to 2 and 2, and 6 breaks down to 3 and 2. If you remember from last unit, we circle up our pairs. Pairs go on the outside, so you have a pair of 2's, and you see what you have left. You have a 6 left over. Finally, once you simplify that radical as much as you can, which we did, you look to see if there is any number that goes into 2, 2, and 2, those 3 outside numbers. In this case, there is. 2 goes into everything. 2 goes into 2 once. 2 goes into that 2 once. 2 goes into this 2 once. Our final answer would be 1 plus or minus. It's a 1 radical 6, but you can put it as a radical 6 over 1. And you could even leave it as just, I'm going to write over here, 1 plus or minus radical 6. At this point, I would like you to try the 2 do now problems and see how you do with them.